Okay, Leslie, I wanted to work through these couple of problems because the answer that you submitted, you're saying that it goes from 5 and it stops at -1, but the correct answer was negative infinity to 5, it stops at 5. So I wanted to work this one. I'm going to take this apart. So 3v plus 5 is less than or equal to 20, or 4v minus 6 is less than -10. So I'll subtract 5 from both sides. So 3v is less than or equal to 15. And then I'll divide by 3. So v is less than or equal to 5. Or I'll add 6. So 4v is less than -4. I'll divide by 4. So v is less than -1. Okay? So if you'll notice right here, I do not reverse my symbol because I divided by a positive, not a negative. Okay? So now, I'm going to draw a number line, and I'm going to illustrate both of these on the number line. So I know I'm going to need a -1, and I know I'm going to need a 5, so I can see all that. So I'm going to start at -2, -1, 0, 1, 2, 3, 4, 5, and 6. Okay, so above this number line, I'm going to show you each piece. So this piece says v is less than or equal to 5. So that means that I would have, old school, that would be a closed circle. Like when I went to high school, that would be a closed circle. Okay? But now we use this interval notation. So I would have a bracket, and because it's a less than, it's going to be going this way. So this is a picture of v is less than or equal to 5. Okay, so now v is less than -1. Old school, that would have been an open circle, right? Okay? And I would be at -1, and it's a less than also, so it's going this way. Okay? So my less than, sorry, I put an open circle right there. It should be a parentheses. Alright, so now this is a compound inequality, and my connecting word is an or. Okay? So or means that I need either this one or this one. So my solution can either be on the blue line or it can be on the green line, and they're both good. So that means I need to include everything on the blue line and everything on the green line. So if I include everything on the blue line, then my answer has to start here. So I would have to start my answer solution right here to include everything on the blue line that I drew, and then all of this is the blue line, right? And then I hit, this is still the blue line, then I hit the green line, but remember it could be here or here, so I can be blue or green. So I need all of that in the arrow. So this or this means I need either piece is good. Either one. I can be on this line or on this line, and it's still a good answer. So the interval notation, remember you always write your interval notation from the smallest value, comma, the largest value that you've shaded, and you either use parentheses, that's your open circle, old school open circle, or brackets, that's your old school closed circle, okay? So arrow always gets a parentheses because there's no such number, so we can't close it in. So I have to go from -infinity, that's the smallest value on this number line, and I go all the way to 5, and then I have to stop at 5. So here is problem number 5 from your review. Okay, problem number 5. Then I want to look at problem number 17 from your review. So problem number 17, it says factor completely. The very first thing that I notice is I have a 75 and a 27, and I know they have a common 3, and you knew that too. See, you got that common 3 right there, right? So I take that common 3 out, and the question is, what am I going to have left over inside the parentheses? Well, to figure out what I have left over inside the parentheses, I divide these by that common 3. So 75 divided by 3 is 25, and 27 divided by 3 is 9. See, you wrote 7, but it's 9. Okay? And then this was a y squared. So now inside of this parentheses, I have to factor it again. Factor it again. Because as I look at this, I see that it's a difference of squares. A difference of squares, I take the square root, so the square root of 25 is 5. I take the square root of 9 is 3. The square root of y squared is y. And that gets a repeat, okay? Because a difference of two squares means that my insides and my outsides zeroed out, so I need a plus and a minus to make them zero out. So here was the final answer right here for problem number 17. Okay, now let's look at the next one I wanted to go over, which is problem number 18. It's another factoring type problem. Although this one says solve an equation that's already in factored form. So that's telling me that's already been factored? Yeah, it has, because I got two parentheses. They're being multiplied together. That's what factor means. Factor means things that are multiplied together. Okay? So the only thing I have to do for this one is use the zero product property. And what that property says is that if two things are multiplied together, A times B, and that's equal to 0, well, in multiplication, for something to be equal to 0, then one of them had to be 0, right? Or both. So if this one is 0, okay, then that would make it still equal to 0. If B was 0 when you multiply, because this would be A times 0, that would still make it 0. So what the zero product property says is, it says break these factors apart and suppose that they're equal to 0 and solve them. So solving the first one, I subtract 3 from both sides. And so I get y is equal to -3. And then solving for y, I add 5 first, and I get 3y is equal to 5. I divide by 3, and I get y is equal to 5/3. So my two solutions were y is equal to -3 or y is equal to 5/3. Now, the other two problems that you missed, if you notice, I went back in and I adjusted your grade. You missed two problems. You got the numerical portion of the answer right, but they wanted you to write it out using inequalities. And I think that was number 8, number 9. Go back and you can maybe look at those. Okay, so I hope this helps.